Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 6 of Intermediate R. Now, the material is at chriswoods.com/intermediate-r, and now we're on to the Tidyverse section. Now, as mentioned before, R is an old programming language that was rewritten as a reimplementation of an even older language, which was S. Now, over the years, this has meant that R has gained many different layers and many complicated and slightly conflicting ways of doing things. This has created a lot of inconsistency and craft, and R sometimes behaves in a strange and unexpected way that can be confusing for new users and not really suited to applications in modern data science. Now, to fix this, a group of people, predominantly led by Hadley Wickham, have created the Tidyverse. The Tidyverse is a coherent collection of modern R packages that solves the problem. It's a coherent system of packages for data manipulation, exploration, and visualization that all share the same common design philosophy. Now, the packages were originally mostly developed by Hadley Wickham, but they have been expanded by several contributors and have now developed into a thriving and highly supportive community. So, modern R is really the Tidyverse, and I would strongly recommend that when you use R, you use the Tidyverse for your data science, manipulation, and visualization needs. Now, there's lots of information about the Tidyverse on the web. We're only just going to touch on this and sort of introduce this in this workshop. But if you want to go further, we've got a couple of links here of what is the Tidyverse, and then particularly here the R for Data Science book, which really teaches the concepts of tidy data and shows how R with the Tidyverse can help you create tidy data workflows. And when you hear me say tidy data, we will cover what we mean by tidy data in the next workshop, Introduction to Data Analysis with R. Now you can load the Tidyverse, and if I just clear this, by basically first making sure it's installed. So as we saw in the first part, we do install packages, and then we type in Tidyverse, and hopefully you either already have it installed, because sometimes it is installed by default, but if not, what will happen now is it will go through and it will make sure that everything is then installed for you. Now the Tidyverse is a whole collection of packages, it's not just one package, and all of these packages subscribe to the same design philosophy. To load the package, to load the Tidyverse, we just type library Tidyverse. And indeed, nowadays, when you look at any R script, you'll probably see library Tidyverse written at the top of pretty much every script. What this will now do is it will load every single package that is part of the Tidyverse. So you can see here, these are the packages which are part of it. So we have ggplot2, which is used for graphs and graphical visualization. We'll be covering this in the next workshop. There is Tibble, which we'll be covering very soon, Tidyr, readr, per, dplyr, and forcats, and I apologise for mispronouncing any of these. When you hear people talking about R, you will probably hear these terms quite a lot, and people will talk about dplyr and others. Again, we will be going through these through this workshop and through the next workshop. Now there's a couple of conflicts here. Do not worry too much about this. What this is saying is that the new filter function from dplyr has replaced the old filter function provided by the old stats package, in the same way the new lag function has replaced the old lag function. This is completely fine. The Tidyverse is updating R effectively and giving you new versions and better versions, to be honest, of many of the existing old functions. Now this brings us to our first exercise. What I'd like you to do is I'd like you to install and load the Tidyverse. Now there are links above, so the links that we have here, and they will kind of like, as well as using the help function as well within the help, enable you to see what these libraries exactly are and how they work, and I'd like you to just explore those for just a little bit. Press pause, and when you come back from pause, I will go through the answer. Okay, you've now unpaused, that means you're now ready for me to give you the answer to this question. So, from the links that we can see here, so ggplot, Tibble, Tidyr, readr, etc., we can actually find out what these individual packages are doing. So if we click on ggplot, this brings us to the ggplot book, and this is basically a book that shows you how to use ggplot. And we can see that ggplot is basically a graphing package. It's a package for creating fantastic graphs and visualizations, built on the concept of a grammar for graphics, which once you understand it, provides a straightforward and consistent interface for creating sophisticated graphs and plots of tidy data. We have Tibble. Now Tibble, if we click on this, is a modern reimagining of the data frame, and you were going to be covering this pretty much after this exercise. It's a much cleaner version of data frame which is more consistent and better suited to the needs of modern data science. We have Tidier. Tidier is a package which helps you create tidy data. Now the whole Tidyverse is built on this concept of tidy data, and while we'll go through this in much more detail in the introduction to data analysis with R, just to say tidy data is where every column in your table is a variable, every row is an observation, and every cell is just a single value. Now typically real world data does not come in a tidy format, and so you need to munge it around to make it tidy, for example by pivoting it, rectangling it, nesting it, etc. The Tidier package provides the functions which enable you to do this in an efficient and clean manner. Now the readr package, we'll be covering this very soon. This is basically a way to functions which enable you to read rectangular data, so read tables of data. So it's modern versions of read.csv, and so here we can see it can read CSVs, tab separated files, etc. Again, I've linked to these pages because every single one of these packages come with these fantastic cheat sheets. So if we look at this here, the cheat sheet is a large PDF and effectively is like everything you can do with this particular function or this particular package. Again, if you're learning R, these cheat sheets are absolutely invaluable. And again, the documentation is fantastic. We can't cover all of this in one workshop. Then we have Purr. Purr is basically a functional programming toolkit. We'll come to this probably in applied data analysis with R, and it's a way of enabling you to perform functions on specific bits of data. So for example, mapping and analysis across every single column of data, or every single item of data. We have dplyr. This is a grammar for data manipulation. So again, this is how you will be selecting data or changing data, or updating a row, updating a column, summarizing data, creating averages, filtering out things you don't want. We'll be covering this function in the Introduction to Data Analysis with R workshop. And then we have forcats. And what this does is basically it's a way of handling categorical data. So data which basically has a set category, set values. So for example, here we have the data is going to be human, droid, Gungan, Wookiee, etc. So it's not data that's variable, it's data which has categories, red, green, blue, orange, etc. And this just provides a much cleaner way for R to handle this categorical data. Okay, so those are the 7 modules that today make up the Tidyverse. We may find there'll be more in the future. And again, as you've seen here, we've got great documentation that'll help you look at them. Now, what we're going to do now is the 2 we're going to concentrate on are Tibbles, which is the update to data frame, and readr, which is an update to read.csv. So let's now move through this. Now, as I said, we're going to learn about the Tidyverse in much more detail in later workshops. It's a very rich set of libraries that will really help you do data analysis and data science. For today, we're going to look at Tibble. And Tibble is the modern Tidyverse version of a data frame. Now, a Tibble is a data frame, so a Tibble and data is like an extension of a data frame, so you can use a Tibble in the same way you would have used a data frame, but there are much more powerful features attached to a Tibble, and there's also some inconsistent and confusing behaviour of data frames that has been removed. I showed you data frames in the last section just so you knew what they were, but to be honest, in the future we will only be using Tibbles. Now, in the same way as Tibble is a modern version of a data frame, readr provides modern Tidyverse replacements for R's standard reading functions. So readr provides an update to read.csv, and instead of read.csv, it's read_csv. And this is the updated version of read.csv, and instead of returning a data frame, this will return a Tibble. So we can now load up our cats dataset. So remember before we had this from this web address. I'm just going to copy and paste this in so I don't type this wrong. There we are. And now instead of using read.csv, we're using read_csv, and this will use the readr function to read this comma-separated value file, and it will then output a Tibble. Now what you've noticed is that the Tidyverse, when it's read the file, has now printed out some very useful information. This is the first thing that's an advancement of being able to use the Tidyverse. It's told us immediately that this file contains 3 columns. The first column was sex, then there was body weight, and then there was heart weight. And then as well as telling us the column names, it's also telling us what the Tidyverse thought was the type of data that was contained within those columns. So the Tidyverse here thinks that the sex was a character, so it was a set of strings. The body weight was doubles, and the heart rate was doubles. So this is really good. It means that we're able to now use the data with the right type that is necessary. Now if I just clear this and I now type cats and hit return, what you'll now see is, if you remember last time when we typed cats, it printed all of the rows out and it flooded my screen. With the Tidyverse and with a Tibble, it will only print out just some of the rows so that we have a quick view of what this data contains. So you can see here we have a summary. The Tibble is 144 rows by 3 columns. We have a nicely formatted column names. We then have the type of the column, so character, so string, text. Here's double for a floating point number, and again double for a floating point number. And then we can see these first 10 rows, and then we get told there are some more rows that we're not going to print. This behavior of a Tibble, that it only just prints a summary, is very useful when you're quickly looking at data. To note, if I double click on it, it's still all of the data, it all exists, but we're not flooding our console with that data. Now, as a Tibble is a data frame, so it behaves in the same way as a data frame, you can still use the same way of operating with it as you did with a data frame. So the name with $, and then the column name will give you that column. In the same way, if I want to have the first row, I can do cats square bracket 1 comma, and that's now given us the first row. Notice that it's given us the row as a new Tibble. So we've not basically gone back to having just the data itself. And so whenever we take any bit of data from this, again, we get the sub-Tibble, and if we wanted to just have the data on its own, we have to basically use the double square bracket as we had before. Okay, this has now brought us to the next exercise, to the final exercise for this section. I would like you to load the cats dataset into a Tibble using read_csv. I'd like you to use your calculate mean and calculate max functions from before to calculate the mean and max body weight and heart weight of the cats. Now, information about this dataset is contained, if we look here at this page, what are the units of the weights? So before, when we printed them out, we printed out just numbers. It's never a good idea when you're working with just numbers to not include the units. So could you make sure this time we actually include the units in the printout? Again, press pause, and when you unpause, I will show you the answer. Okay, you've now unpaused, which means that you're now ready for the answer. So I'm going to come across, just clear this. So the first thing is, remember, we have to load the Tidyverse. So we do load library Tidyverse at the top to load it up. Then we have to load up the cats. So we're going to assign that from read_csv, and then the name of the link for the file. So I'm just going to find the link, copy and paste it from here. There we are. That way I don't have to try and remember it and make a mistake. So now that's read all of the values within this cats.csv file into a Tibble, and we've got this like summary specification of it here, and we're kind of quite happy with that. Now, like we did before, we're now going to create the mean heart weight, which will pass into the calculate mean. And again, because the Tibble is a data frame, we can use it in the same way. So that means we can do heart weight like that. Then mean body weight is from calculate mean, cats, then body weight, and then we're going to have max heart rate. Do you find that very difficult to say those two things close to each other? So the max one is going to be calculate max from cat's heart weight, and then the max body weight is from calculate max cat's body weight. Now I want to print this out now, so we're going to do cat sprintf heart weight colon mean equals %.2f. But now I said we need to use the units. So what are the units of heart weight? So if we go look at the information about the data, we can see here that the body weight is in kilograms and the heart weight is in grams. And so what we've got here is the heart and body weights of samples of male and female cats used in this particular experiment. And all of the cats were adult over 2 kilograms of body weight. So this means the heart weights here are in grams. So we're going to put G there, and max equals %.2f, grams, new line. Oh, and I forgot to put the variables in. So, mean heart weight, and then max heart weight. There we are. 10.63 grams and 20.5 grams, the same values as before. We can do the same thing for the body weights. So we do body weight, colon, mean equals %.2f. And remember this time, the body weight was in kilograms. That's why these values appeared to be smaller, but it's basically a higher weight unit. So let's do kilograms there. Max equals %.2f kilograms. New line. And then here we do mean body weight, max body weight. There we are, the mean body weight is 2.7 kilograms, the largest cat was 3.9 kilograms. Okay, so that's now brought us to the end of this section of the workshop. So we've now completed part 6. We can now move on to part 7, where we're going to look at forward pipes. I look forward to seeing you there.